Hi students, I am DR.G.SUDHA, Assistant Professor of Mathematics, A.D.M. College for Women, Nagapattinam. Today we are going to see the topic differential geometry. Already we were discussed many topics on this area. Today we are going to direction coefficients on a surface. Already we were discussed in some modules. First definition is direction of any tangent line to the surface at a point P is called the direction of the surface at the point P. And then tangential vector, let B be the unit vector along the tangential vector A at P. Already you know the unit vectors, T vector, N vector and B vector. All T and B are the unit vectors. Here the B be the unit vector along the tangential vector A at P. Let the components of B vector be L, M, so that B vector equal to L into R1 vector plus M into R2 vector. R1 vector, R2 vector already you know very well. These are the position vectors. The components L, M of the unit vector B vector at P along the direction A are called the direction coefficients of A vector. These direction coefficients are written as L, M. From the definitions of L, M minus L, minus M gives the direction opposite to the directions L, M. Let's go for the first theorem. Here L, M and L dash, M dash are the direction coefficients of two directions at a point P on the surface, and theta is the angle between the two directions at P. Then cos theta is equal to E L, L dash plus F into L, M dash plus L dash M plus G, M, M dash, and sin theta is equal to H into L, M dash minus L dash M. Sin theta and cos theta are the direction cosines. Already A dot A dash equal to cos theta we were discussed in the previous modules, and sin theta is A cross A dash into N vector, isn't it? We have to prove that the cos theta value and sin theta value here. Let's go for the proof. If L, M and L dash, M dash are the direction coefficients of the two directions at the same point P on the surface, R vector, position vector, R vector is equal to R vector of U comma V. Then the corresponding unit vectors you know well, T, L, N, B along the direction at P or A vector is equal to L into R1 plus M into R2, and A dash vector is A dash means differentiate with respect to S. Dash vector, dash means with respect to S and dot means with respect to U. You know well. That is A dash is equal to L dash into R1 plus M dash into R2. Take it as equation 1. Then theta be the angle between the two directions. Measuring theta from the direction R1 and R2 through the smaller angle. We have A dot A dash. Already I told just now A dash is equal to cos theta and A cross A dash is equal to sin theta into N vector. Dot product of A dash is cos theta and cross product of A dash is sin theta into N vector. N is the normal vector. That is the equation 2. Now we have to take the dot product of A dot A dash. Already mentioned the A vector and A dash vector is mentioned the above step. A vector equal to LR1 plus MR2 and A dash is L dash R1 plus M dash R2. We are taking the dot product of these two, L into L dash R1 dot R1. R1 dot R1 is R1 squared plus L into L M dash R1 R2 and L dash M into R1 R2. Taking common taking R1 R2, take it out, L M dash plus L dash M into R1 R2 plus the last one M into M dash R2 into R2. R2 dot R2 is R2 squared. So we get L dash R1 squared plus L M dash plus L dash M R1 dot R2 plus M dash into R2 squared. Here that is equal to E R1 squared, the value of R1 squared you know well. What's the value of R1 squared? And R1 dot R2 and R2 squared. Already we were discussed in the previous modules. The value of R1 squared is E and the value of R1 dot R2 is F and the value of R2 squared is G. So that E into L into L dash plus F into L m dash L dash m, that is R1 dot R2 is equal to F, and the last one m into m dash R2 squared, that is G. So G m m dash, take it as equation 3. Using equation 2 in 3, we get cos theta is equal to E L L dash plus F into L m dash plus L dash m plus G m dash. Further, A cross A dash, already A dot A dash the value in the previous slide. Now let us go for the cross product for A and A dash. Taking cross product, L R1 A value L R1 plus M R2 and A dash value is L dash R1 plus M dash R2. The value of R1 cross R1 and R2 cross R2 0, and the dot product is 1, but the cross product of the same vectors is 0. So that R1 cross R1 and R2 cross R2 is equal to 0. I have A cross A dash L m dash plus L dash m into R1 cross R2. Using 2 in 4, we obtain the value sin theta is equal to L m dash plus L dash m into h, where h is equal to square root of Eg minus f squared. When the two directions are orthogonal, then cos theta is equal to 0. You know well, when the two directions are orthogonal, then cos theta value becomes 0, which gives the terms of the direction coefficients. So cos theta equal to 0. What's the value for E L L dash plus F into L m dash plus L dash m plus G into m dash value is equal to cos theta 0, means that the whole term tends to 0. So that E L L dash plus F into L m dash plus L dash m plus G m dash is equal to 0. So an important result from this theorem we were discussed in the first theorem, isn't it? So that from this theorem we can easily get tan theta value. What's the tan theta value? H into sin, both we were discussed sin theta value and cos theta value. So that sin by cos tan theta, isn't it? So that tan theta is equal to H into L m dash minus L dash m divided by E L L dash plus F into L m dash plus L dash m plus G m dash. Next, let us go for the direction ratios definition. What's the direction ratios of the direction? If L, M are the direction coefficients of a direction at a point P on the surface, the scalars lambda comma mu, which are proportional to the scalars lambda comma mu, which are proportional to L comma M, are called the direction ratios of that direction. Then now we are going to theorem number 2. If L comma M are the direction coefficients of a line which makes an angle pi by 2 with a line whose direction coefficients are L m, then L dash is equal to minus 1 by h Fl plus Gm, and m dash is equal to 1 by h El plus Fm. We have to prove that L dash value and m dash value when theta is equal to pi by 2 and a value of L dash and m dash. We have to find the values. Now let us go for the proof. If L comma M and L dash comma M dash are the two directions at a point on the surface, then by the previous theorem, that is theorem number 1, what's the value for cos theta? Just now we were discussed, isn't it? So cos theta is equal to E L L dash plus F into L m dash plus L dash m plus G m dash, and sin theta is equal to H into L m dash minus L dash m. Taking equation, these are the equations 1 and 2. When theta is equal to pi by 2, we have from equation 1. Theta is equal to pi by 2 means equation 1 cos theta, that is cos pi by 2. What's the value for cos pi by 2? Yes, cos pi by 2 means 0. E L L dash plus F into L m dash plus L dash m plus G m dash is equal to 0. Here L dash is L dash and m dash are both repeated terms. So take it L dash outside and m dash take it outside. So we get L dash into E L plus Fm plus m dash take it out, balance m dash into Fl plus Gm is equal to 0. The above equation is satisfied for L dash. From the above condition, L dash is equal to minus alpha into Fl plus Gm and m dash is equal to alpha into El plus Fm. That is equation 3. For some scalar A, we shall find A with the help of equation 2. That is the previous slide. When theta is equal to pi by 2, we have from equation number 2, what's the value for h into L m dash minus L dash m? Is the value is equal to 1. That is equation number 4. Using equation 3 and 4, what's the value? We obtain HL into alpha into EL plus FM plus HM into alpha into FL plus GM is equal to 1, which gives alpha is equal to H into EL squared plus 2F ML plus GM squared. This is the value for alpha. Since L, M are the direction coefficients, you know well, isn't it? Since L, M are the direction coefficients, we have EL squared plus 2FML plus GM squared. L dash is equal to L, M dash is equal to M, we get EL squared plus 2FML plus GM squared is equal to 1, so that alpha is equal to is 1 by H. Using this value of alpha in the previous one, equation 3, we obtain L dash is equal to minus 1 by H FL plus GM and M dash is equal to 1 by H EL plus FM, isn't it? Are you all clear? Shall we move the next example? Yes. First example, find the parametric directions and the angle between the parametric curves. Find the parametric direction and the angle between the parametric curves. For the parametric curve is equal to constant, the parametric direction has the direction ratio du, 0 by v. Using the first one, its direction coefficients Lm is du, 0 divided by square root of e du squared. Du means that is equal to 1. So 1, 0 by square root of e. In a similar manner, the direction ratios of the curve is equal to constant are 0, dv. Already we were discussed du, 0. Here the v is equal to constant means 0, dv. So that its direction coefficients L dash, M dash. Already we were discussed L, M. Here L dash, M dash direction coefficients. So 0, dv divided by square root of g dv squared. dv that is equal to 1. So 0, 1 divided by square root of g. Let theta be the angle between the parametric curves. Then by the first theorem, cos theta is equal to f by square root of eg and sin theta is h by square root of eg. When theta is pi by 2, cos theta is equal to 0. Value of cos pi by 2 is 0. So that cos theta is 0. So that the condition of orthogonality of parametric curves f equal to 0. Since cos theta is equal to f by square root of eg. Cos theta is 0 means f equal to 0. Yes. It should be noted that we have obtained the angle between the parametric curves by considering R1 dot R1 and R1 cross R2. Then let us go for the example 2. First one, the direction coefficient and direction ratios is discussed here. Find for the cone with the vertex at the origin and semi-vertical angle alpha and the axis of the cone as the z-axis is r vector is u cos v, u sin v, u cot alpha. The position vector r is taken as x vector, y vector, x, xi plus yj plus zk. So x, y, z we were usually taken. So r is x, y, z. Now let us find the fundamental coefficients. R1 is R1, R2. Fundamental coefficients, what does mean by fundamental coefficients? Yes, very good. E, F, G, H square, H are the fundamental coefficients, isn't it? Okay. Now let us find the fundamental coefficients. R1 vector. How do we find R1 and R2? Yes, R1 means differentiate R vector with respect to U, and R2 means differentiate R vector with respect to V. So we get R1 vector is U into cos V. I take it U means variable. Here we assume the variable U. So cos V into 1, U into sin V. Here the variable as usual U. So sin V into 1, sin V. And last one is U cot alpha. Cot alpha into 1, cot alpha. So R1 is cos V, comma sin V and cot alpha. And R2 means differentiate R vector with V. Okay. R2 is equal to U into U cos V. Differentiate cos V with respect to V. So that minus U sin V and U sin V. That is U into sin V differentiate panam using differentiate V R with respect to V. Hence U into cos V and U cot alpha. That is there is no V term in the last term. Okay. Yes, U cot alpha, differentiate U cot alpha with respect to V. There is no term. Hence 0. What's the value for E? Yes, very good. E is equal to R1 dot R1. Taking dot product R1 with itself. So R1 dot R1 is equal to cos V into cos V, cos squared V plus sin V into sin V, sin squared V plus cot alpha into cot alpha, cot squared alpha. Sin squared V plus cos squared V is equal to 1 plus cot squared alpha. So we get the value 1 plus cot squared alpha. Using the value of 1 plus cot squared alpha, cosecant squared alpha is. What's the value for F? Here the value taking dot product of R1 and R2, we get the value, isn't it? There is no common term R1 dot R2. Cos V into minus U sin V, minus U sin V cos V plus U sin V cos V plus 0. So we are crossing each other, U sin V cos V minus U sin V cos V plus U sin V cos V, cancelled each other, and the last term is 0. So we get F value is 0. Next let us go for G. What's the formula for G? Yes, R2 dot R2, R2 squared, taking R2 dot product with itself. So minus U sin V into minus U sin V. So U squared sin squared V plus U cos V into U cos V. So U squared cos squared V plus 0, isn't it? So U squared common for two terms. So U squared take it out, balance U squared into sin squared V plus cos squared V. So that U squared into 1 is equal to U squared. Then we found E, F, G. Next H squared. H squared, you know well, H means square root of EG minus F squared. Directly we have to take H squared. Without square root, we are taking H squared. So that EG, H squared equal to EG minus F squared. Already we found E value, G value and F value. Directly substitute the value for these. E into E value cosecant squared alpha. G value is U squared, so that E into G, U squared cosecant squared alpha. F value is 0, so minus 0, so that we get H is equal to U cosecant alpha. Hence N vector is equal to, what's the value for N? N is equal to taking cross product of R1 R2 and divided by H. Yes, so R1 cross R2 divided by H is equal to R1 cross R2 minus cos V cos alpha minus sin V sin alpha, comma sin alpha. Thus the surface normal capital N is independent of U. This implies that the tangent plane is same at all the points along the generating line. Are you all understand, students? Yes. Shall we move the next example? Okay. Example 3. For a right helicoid given by U cos V, U sin V, A into V. Determine R1, R2, N vector at a point on the surface and the direction of the parametric curves. Find the direction making angle pi by 2 at a point on the surface with the parametric curve V is equal to constant. Just now we were discussed, isn't it? R1, R2 and E, F, G. Here also the same procedure following. Now any point on the right helicoid, R vector equal to, take it as R vector for a right helicoid given by R vector is equal to U cos V, U sin V, A V. You know well the position vector R vector is equal to X comma Y comma Z, isn't it? So R1, what does mean by R1? Yes, very good. Differentiate R vector with respect to U. That is R1 is equal to cos V into 1, sin V into 1. There is no term in the last U term in the last term. So A into V, there is no U value, hence 0. Next R2, differentiate R vector S with respect to V. So R2 is equal to minus U sin V cos V, differentiate with respect to V. So minus sin V into U, U into cos V, last term A into 1. So A. The value of R1 and R2, R1 taking dot product R1 with itself, so that E value. So R1 dot R2 is equal to 1 and F is equal to taking dot product of R1 with the R2. There is the terms are cancelled, so that cancel each other, hence the value of F is 0. The value of G, taking R2 with taking dot product of R2 with itself. Yes, very good. G is equal to U squared plus A squared. Like the previous sum, we are following the same principle here. H squared, what is the value for H squared? Do you all remember? Yes, very good. Square root of H means square root of EG minus F squared. Here we are going to calculate H squared, so that EG minus F squared without square root. E value already we then R1 dot R1, that is 1, so E value 1 and G value is U squared plus A squared. So 1 into U squared plus A squared minus F is 0. So that H squared is equal to U squared plus A squared. Taking square root, so H is equal to square root of U squared plus A squared. Next we will move on the cross product for R1 and R2. So taking cross product R1 cross R2, how do we calculate the cross product for both the vectors? Yes, taking determinant value, we get R1 cross R2, A sin V minus A cos V, comma A. After calculating the determinant value, we get the cross product. Now n vector, normal vector is equal to R1 cross R2. Formula, already you know the formula, capital N, that is normal vector, is equal to R1 cross R2 by H. We were just found the value R1 cross R2, A sin V, H means what? Square root of U squared plus A squared. Substituting the value for R1 cross R2 by H, we get the value n vector, A sin V by square root of U squared plus A squared minus A cos V, second term, V, U, X, Y term, minus A cos V, so minus A cos V divided by square root of U squared plus A squared, and the kth term is A. So A by H means A by square root of U squared plus A squared. Let the components of n vector means what? N1, N2, N3. Yes. Using the second one, the direction coefficients of the parametric curves are 1 by square root of E, 0. That is E value 1. Substitute here 1 by 1, 0 means 1, 0. And the second component 0, 1 by root G. G value U squared plus A squared. Taking square root 0, 1 by square root of U squared plus A squared. If gamma is the angle made by n vector with z axis, then cos gamma is equal to n3. n3 means U, last one, n1, n2, n3. U by square root of U squared plus A squared. If L dash, M dash is the direction coefficients orthogonal to the parametric direction, V is equal to constant, then by the second theorem, just now we discussed, isn't it? So then by the second result, L dash is equal to minus 1 by H F into L plus G into M, and M dash is equal to 1 by H into EL plus FM. Substituting the value for L, M, E, F, G and H in the above step, the previous steps, we have L dash is equal to, substituting the value for L, M, E, F, G and H in the previous step. This one L dash, that is minus 1 by H into FL plus GM. We have to get, we are getting L dash is equal to 0. So that M dash and M dash value 1 by square root of U squared plus A squared, substituting the value, and then we get the value answer L dash and M dash, which is the direction of the parametric system U is equal to constant. This is what we expect since the parametric curves are orthogonal, isn't it? You all understand? Thank you, students.